The biggest risk of working as a data scientist in an organization is that you only see the world through the prism of inside the organization, right? You are looking at the data in the org, all your stakeholders are internal, so you have an internal model of reality. But the real reality is that your organization lives inside of a market, lives inside of an ecosystem, lives inside of an economy.
Yeah.
How do you think about those?
Hello, everyone. Welcome to the Data Scientist Show. And if you haven't been enjoying the show, subscribe to the channel, and it will really help me if you give it a 5-star rating on Apple and Spotify. Today, we have Amit Gandhi. He is a technical fellow and VP at Airbnb. He's a professor in economics at Wharton School from the University of Pennsylvania. Previously, he was the chief economist at Microsoft Azure. His research focuses on the use of data in economic models and decision-making processes, whether at the organization, industry, or individual level. Today, we'll talk about his career journey, decision-making, machine learning, economics, and his advice to data scientists. Make sure you stick to the very end. Welcome to the show, Amit.
Yeah, happy to be here. Thanks for the invite. This is a delightful introduction.
Can you give us an overview of your career journey?
Sure. Let me give you a little life story as well. Maybe you sort of grew up in Ohio, was born and raised here in the U.S. And my parents are physicians, and I come from an Indian heritage, and so there's a lot of interest in making your children into doctors. And so for the longest time, I thought I was going to be a physician until I think when I was in college, I went to the University of Michigan. I got exposed to an economics course, and it really just rattled my mind because I saw those concepts and I immediately thought about businesses. I said, oh, wow, like this must be how businesses work, that we can look at economic concepts and understand customers and suppliers. And I sort of created this fantasy world of how business enterprise operate. And I assumed that's what an economics career would entail. So I kind of quickly pivoted, if you will, in that direction, much to my parents' chagrin. But I think I focused heavily on the intersection between sort of economic concepts and data structures, and I was almost interested as well in a little bit of philosophy, which is how do people come to learn? How is knowledge produced? Like, what does it mean to learn? What does it mean to produce knowledge? That gets a little bit into almost epistemology. So I started to see this very interesting connection between economics, data, and like foundations of knowledge and information. And the only place to sponsor such bizarre and abstract thoughts was really to get a PhD. And so I wasn't quite ready for the working world yet. So continued to get my PhD. I did have some interest, though, even then. I'm a child in the 90s, 1990s, just to be clear. And it was sort of the dot-com boom when I was, the first dot-com boom, when I was kind of coming out of college, going into grad school. So I actually did play around with the idea of jumping into, just a startup. So so many ideas were in the air, and we had an early e-commerce idea. So I was very conflicted by those two worlds. But just to fast forward, I then went down the more traditional academic pathway, if you will, kind of produce research, create a thesis, get an assistant professor job, get tenure in the assistant professor job, become a full professor. You go through this whole academic hierarchy, but really at some point you want your ideas to get applied in the world in some fashion, and there's lots of avenues and conduits for it. I just think with data becoming such an asset, it just felt very natural to move into a technology company. And so I started to sort of revolve door out of academics, and I spent some time at Microsoft, really my first true embedded corporate experience, because I think a lot of academics have relationships with companies whereby they are consulting. And I think to be embedded or part of the organization versus consulting for the organization are two very different relationships. And I was familiar with the consulting model. I was not familiar with what does it mean to become an sort of an insider, if you will, and become part of the culture. Because I think as a consultant, you're being hired for your expertise. As part of an organization, you're being hired to help move an organization. Those are two very different jobs at some level. And I just became really intrigued by the idea of working with people and scaling. We all want to scale our ideas, and scaling can happen obviously through information systems and technology, but it also happens through people and relationships and human structures as well.
Yeah.
So anyway, that's kind of the long and the short of it is, so I spent some time at Microsoft. My wife joked with me that I got my, I was there for 6 years, so got my second PhD and with that, I became interested in maybe, Microsoft is primarily an enterprise business, as you probably know, and they work a lot with enterprises. To work with a consumer-facing business was sort of on my list of interests, because from a data perspective, those can look rather different, and the kind of data technique you can use and the kind of decisions that have to get made. So I'm now at Airbnb, and I'm very excited to be here as a technical fellow and vice president, as you mentioned, and just trying to help, I think, take their product to the next level of what's happening in the travel economy and this new world of remote work and live anywhere. I think it's quite exciting.
Yeah, thanks for sharing that. And previously you mentioned that going into the industry, especially being part of the organization, is different from being a consultant. So maybe let's start with your experiences at Microsoft. So when you just joined the company, when you just started your industry PhD, what is the kind of biggest culture shock that you experienced from a background in academia?
It's rather different. I think one is just how you position your ideas has to be done a little bit more artfully. I think in academics there is almost an ethos of being brutally direct about the concepts, and the debate is really about getting to some understanding of an abstraction. Now, of course, people have anytime you work on an idea or a research paper or a business concept, I think it's natural for people to have an emotional relationship to it as well. I don't think emotions are that different between academics and industry, but I think you have to sort of be much more measured about having those conversations inside of an organization, and also humble yourself. I think academics and myself, I put myself in this bucket, we like to rest on our laurels. We have all this great pedigree. We have all this expertise. We assume the world wants to listen to us. But I think what's new about coming to an organization is that you almost have to develop your credibility from scratch. And that really requires doing it in piecemeal versus, here's this solution I have for you. Why don't you go apply it? So I think it's just the process is a little bit different. But there is a lot of good in academics that I think can help some organizational processes and systems with just trying to understand complex problems. I mean, I think what connects business and industry with academics is that these are very hard, complicated problems at the end of the day.
Yeah.
And I think, researchers have been spending hundreds of years unpacking very complex, multi-year issues. I think a lot of industry is focused on the quick wins, which is important because you want to make progress. How do you merge those two worlds? I think it's a very interesting problem.
Yeah. So besides going deeper in research problem, what are something that people in the industry, specifically for data scientists, engineer, can learn from, researchers in universities?
Quite literally, project structure. I mean, something as basic as how do we define a problem what are the data sets or data points we want to put up against it? How do you iterate on an ambiguous situation? And I
Yeah.
think kind of that's where the approach in research is sometimes different than the approach in industry. And I think, things go in cycles. And I think there's been a lot of push in industry to get very execution oriented, right? I think for the last 15 or 20 years, it's been about ideas don't matter. It's all about execution. And I don't want to, that's a caricature. That's an extreme version. But there's a notion that just do something. And I think something I've sort of discussed with colleagues and friends is that, we've gotten so good at execution now, like agile and these methodologies for fast and efficient execution are really quite robust and developed. This is a great time to go now explore how do we go generate ideas in the first place, right? Like where do good ideas come from? And that is something where I think the research world really has a lot to offer the private sector.
Yeah. Yeah, thanks for sharing that. And especially from my own experience, sometimes when you have some data set, you do some analysis, you don't really know whether the insights you generate is correct, but the leaders kind of ask you, you need to make a decision using the data. So it's like you mentioned, very kind of action driven. And sometimes you don't know whether you have enough evidence to support an action, but people like to hear a story based on some data, right?
Yeah.
So in your work, when you work in organization, say when you have analysis, but then you don't feel the analysis will support any action, what would you do?
No, and that's also the problem I think some researchers have, which is one of the challenges I guess I also had when I was in academics is, we're producing all this great knowledge. What is the action? Like, what is the, who's a consumer of it? And so it is a problem that with data science, you can definitely look at data, find a lot of interesting insights, sort of patterns, and just sort of storylines you can start to imagine, like, hey, maybe this idea, maybe that idea. I think what's often missing is a process that can use that type of analysis in a broader action taking or decision making environment. And so it's not like, and I think ultimately everything is iterative in nature, right? And so I think about those sort of situations you described as really about hypothesis formation. Like we're looking at data and we're trying to understand, hey, I have this hypothesis, this might be happening. Now I think the action, and this is where I encourage data scientists to push the boundaries of their roles a little bit, which is what should we do about it, right? We have this information, what do we do about it? I think the traditional data science function assumes somebody knows what to do with that information, but I think all of my learning has taught me that that assumption is typically false, is that what's interesting to a data scientist will not be automatically actionable. And so I look at that and say the onus is on the data science to data scientist in that case to then push the conversation further. Like, let's go have a discussion. Look at this. Here's what I think this means. What do you think, business owner? And that usually puts, I think, data science in an uncomfortable position of getting outside of like a purely data space. You're getting into the complexion of the business, if you will. But I think it's essential because that's the big gap that I see in industry, which is there's a lot of data production, but there's not always a lot of catchers. And that gulf in between, obviously the product world is getting closer to data, the data world is getting closer to product, that gap is shrinking. But I do encourage data scientists to take action themselves, to actually say that I think this is an actionable insight. Let's go explore the actions. And I think there's a lot of learning that happens about even your own modeling and data analysis when you realize, oh, wait, this doesn't actually fit a realistic action because I didn't understand something about my company's principles, priorities, or strategies. But if I go back and look at the data with that learning in mind, something makes sense. That's different. And so I think that's a really important element of it. But it is very much a risk of doing interesting research on data that you don't get to an actionable place. Very much a risk. And there's a little bit of a risk, almost like a little bit of a risk-reward trade-off in how the deeper you go, the more interesting it becomes, but the more risk you take in it getting lost in kind of concept and not tying to an actual business outcome.
Yeah. I think you brought up a few very important points. One is when we do an analysis, do we keep in mind what is the business goal we try to achieve, right? Where is the company is going, and try to align the business goal with our own analysis. And also, I like that, we sometimes when someone say, hey, can you give us some number to, I don't know, generate some metrics, give me the data point for last year's sales, ask people why they need this data point. Are they using this for some planning? Are they going to use this to support their assumptions? So you know the bigger picture. And then you can, from a data science perspective, you can tell them whether this ask itself makes sense. So you challenge that assumption, right? And also, in the end, you mentioned risk. So, at least in Amazon, we're encouraged to take calculated risk, because if you only make decisions when you're 100% confident, sometimes you're moving too slow. And it's important to, like you mentioned, the risk reward calculation. Are you, even if the data analysis doesn't support doesn't provide a very clear action, and if the downside is low, do you want to recommend taking the action if it doesn't have a lot of risk, but maybe there will be a big reward when you make the move? So I think it's very important for data scientists to think about the so what question after they finish an analysis and keep aligning with the stakeholders.
Yeah, absolutely. I mean, I think you raised something interesting there, but in the beginning, which is, I think one mode of operation for data science is certainly to address data requests in some fashion. Okay, I need some data point. But obviously that, in my opinion, that version of the data scientist job will get automated away in 5 years. I mean, I think kind of the BI is becoming very robust, and that's a version of BI at some level. And I would actually distinguish data science from BI a bit in that, data science is a structured form of problem solving, and the right relationship a business owner should have towards data science is really about problem solving partnership. Like we want to look at this through the prism of multiple perspectives. And at the end of the day, it's got to be a problem solving approach. And once you have that in mind, then the typical thing that might concern a data scientist, like accuracy, it's no longer first order or second order, because you can imagine being able to take decisions or sort of pursue a business issue where things are maybe 50% accurate or 60% accurate. It's I think the problem with starting it as most good data science problems don't start out as a data problem. It starts out as a hard, ambiguous situation that needs to have structure placed on it. And the sooner you involve the data scientist in that, the more effective is the data scientific output. I think the problems organizations have is they include the data science process way too late in the problem solving apparatus, and as a result, it's a little bit of an add-on. Like, hey, let's sprinkle some data on top. And I think it's really missing the boat on the value of data, because at the end of the day, what we're trying to do is change human cognition. Like we're trying to impact how people see the world. And it's hard. Look, this is not a simple, what I just described to you is not a simple formula that you can just apply, and every company has to do it a little bit differently. But it is important, I think, for data scientists to recognize that they sometimes have to advocate for that position and role inside of a company.
Yeah, I agree with that. From my own experiences, sometimes I feel a problem has already been formulated, and my role is just to fill in some blanks using my analysis. And I agree. Sometimes the organization doesn't really know. It's not like they don't want to. They didn't really understand the entire data science project cycle. So data science need to tell your manager, hey, can you invite me to the goal setting meeting to meet a stakeholder? I think, if your manager have good relationship with you, they trust you, they will love to bring you to the business meeting. And then so you get more context, more big picture of the entire situation, and that will make you a better data scientist.
Yeah. Yeah. And I think also the other part here is just data scientists taking a little bit more of a proactive role in developing a business network inside of companies. I think staying inside of the data science lane, pivoting in terms of, certainly at Microsoft, this was critical to success, is having a network, which I find fascinating as an economist, because one thing I learned about coming into large organizations, and different organizations at different scales work differently, but certainly a large public organization, these work like miniature economies inside of the company, right? So they're in an economy, they're sort of competing in an economy, but there's a whole knowledge economy inside of these companies. At the end of the day, information is vastly distributed, because not everything is going to be contained in a data set. And to really get that context requires a network. So, I think all of this is to say data science is just like any other business function. You have to develop relationships, and you have to form a social and business understanding in order to make your work successful and productive.
Yeah. And you mentioned your experience at Microsoft. So I'm curious, as a chief economist, what do you do? What's your day to day?
Yeah, well, and I think that's such an existential question at some level. It's interesting, because I think when I first came to Microsoft, there wasn't a clear sense of what should an economics function inside of cloud look like, but there was a sense that there was a need. And I think a lot of my first 6 months or almost a year was really understanding how to scope a role. Like where does one, these things are massive structures, massive, almost like planets, like Microsoft's like a planet. Where do you kind of start your journey? What's the right entry point? I think I began with just looking at. I think you also want to look for the pain. Like, where is the I might know X. I'm good at X. My tendency was like I feel really comfortable with these models or these data concepts. And I think I made the usual mistake of kind of trying to start there, like starting with what you know versus what's the need. And I think to understand the need, it took me some time to really listen. You have to get into that. You have to get into that mindset of listening to all the subtle signals, like where are certain words repeated, where are certain problems arising, and once you kind of you gotta kind of find that. For me, I think one area where economics was very natural, and what I discovered was a very hard problem for companies is looking at the long range. I think there's a lot of business process and systems that's very focused on the next 6 months and sort of next 6 months. Most of our delivery systems are kind of semester in nature. But you have a 6-month plan, then you have a 6-month plan, you have a 6 month. So put six-month plans together, all of a sudden that's a 36-month plan. But did you ever think about the 36-month problem? And really, that for me, I started to sort of create this this framework for long range planning. How do you do long range business planning, which products to build, where do you build them, which customers are you trying to suit, but in such a way that it doesn't just stay at this level of worldwide abstraction. How do you take like a worldwide long range view of your business and then drill it down to specific markets and specific customers? That was something I realized that was new. That was a new kind of data science that really hadn't been practiced. I think you might almost call that strategy. That's sort of what McKinsey's and BCG's would do. They would sort of draw up these fantastic long range views of a business model. And when I realized what's powerful about economics, and then in addition, the relationship to data science, is that it can take those same concepts, but get out of PowerPoint. Basically, those are sort of in slides and different visuals, and now we can take those ideas and we can build models around them, and then we can put data structures against them, and in some sense make it real, in a very engineering sense. And that was really where I spent a lot of my initial journey. I always struggled with, once that became somewhat successful inside of the company, in the sense that it had been accepted, decisions were getting made based on this long range view. I always wanted to broaden my scope. Go put this down and work on the next issue. And I did have mentors who would often tell me, every time I started making some headway or started making some success, to double down. Do you continue to kind of create that depth? Because I also think that's something that we often miss in data science, that we sort of want to create a broad portfolio. I worked on this project, worked on that project, worked on this project. Yeah. But really, to have that deep impact, you need that depth of domain. And so I really, stuck to it. I said, look, and because once you have a deep domain, it touches every issue inside of a company. And so things that I was personally passionate about, pricing and segmentation and maybe a variety of other issues, you find some way to connect it with the deep asset your team is developing and your approach is developing. But what I found most interesting about it at the end of the day is, because it was new, it hadn't been done, the data science team we put together was driving the message. We're driving the narrative. We're giving it was very important to me that that the team presented, and I think it's such an important skill. Which is that the elephant in the room is communication, right? You do all this great work, you think about it, you look at it. Can you communicate the results, right? And if you can't communicate it, the value might be very close to zero. That is really the unfortunate reality. And I think a lot of what I saw as the gap at Microsoft was, we have great data, we have a lot of good models, we've got these amazing data scientists, but the message is not being heard. And how do we go create those channels? And so I would say the thing I'm probably most proud of from the Microsoft experience, leaving all the models and data aside, is just putting economics and data science, at the table with these critical business decisions, multi-billion-dollar cloud business decisions. I think that to me was the most exciting part, and it didn't happen automatically. It's not like somebody ever says, here's your seat at the table. You kind of have to wedge yourself into it, but it's not through like politics or through organizational nonsense. It's just through like, these ideas are valuable. Here's what they mean, and really kind of you have to create that advocacy. And one my manager at the time who first kind of brought me into Microsoft, actually former Amazonian. He would I think he had his leadership principles, which I adopted from my team, where maybe they're Amazon principles, but I don't know where he got them. But it was understand deeply, advocate relentlessly, and act courageously. And I think those three. I think data scientists will do the understand deeply very naturally, but now advocate relentlessly and be courageous. And I think that's the other part. Like, you're in a room full of people. speak up, say your piece. I think I'm probably most proud of just that aspect of it.
Yeah, I think that's really important. And you mentioned how to bring data science, the insights on the to the table, and represent it and share the value to the business. Can you give us some examples? For example, how do you translate that insights into business? Do you translate that into like a dollar amount impact or like a growth? How do you do that?
That's a great question. It's such an interesting topic because this is going to sound paradoxical to you, but I'm the economist. I never try to talk in terms of dollars because I think if you talk in terms of dollars, and this is no knock on accounting or finance, it sounds like you're doing accounting or finance, right? Like if you're inside of a product group, you kind of have to talk in terms of what I would often call fundamentals. Like what are the real business fundamentals that we're trying to drive? If we have good fun, and it takes this is also the sense in which I think to be a successful data scientist, you need some almost light MBA perspective on your work, which is to say, if you create value in the world, if you create a valuable service or product or customer success, it will eventually translate into financial success, right? Financial success will come. As an economist, I think about that as the distinction between just a lagging versus leading indicator. Financial performance is great and we all want it, but it's obviously a lagging indicator of doing good work, right? If you're doing good work, that will come. Now, how do you draw what are the right fundamentals you want to study? What are the right fundamentals you want to understand? That's where so when you talk about impact, it's very interesting. I actually define impact psychologically, completely. If you're working on the fundamentals that matter to your business stakeholders, right? Within the business, like if we're just saying, customer success means A, B, and C, then I want to model and study A, B, and C and understand A, B, and C. And assuming that will lead to financial success. Now, I'm not saying the financial piece is irrelevant, but I think there's sometimes a tendency, if you optimize for revenue, you're not optimizing for revenue.
I love that. Yeah.
So you have to optimize for something else that will lead you to the right revenue trajectory you ultimately want. Now, you should still think. I think revenue, cost, margin, these are still considerations you should have, but it's probably not the right way to present your ideas to a large group because I think they're not all focused on that. And I think organizationally, dollars and cents can often be seen as sort of a little bit of a finance exercise. And I do want to distinguish data science from sort of financial exercises. I think they're related, but they're still a bit distinct. And so I focus on variables that matter to our definition of success, which requires, hey, do we have an aligned definition of success? Now, maybe we don't. Now that's a great problem. I would call that a data science problem. Like we need to go define, what does it mean? What are the right fundamentals we should be studying in the first place? Which also takes me back to often the data we need to make sense of an issue is not the data we have. Like it could turn out that the right fundamental is some kind of customer behavior that we think means our product is successful. And it turns out we're not measuring it. It could turn out that this is not in our database or our data warehouse. Yeah. And now that's okay. And I think it's so important to separate the concepts you want to study from the data that you happen to have available. Because ultimately what you want to put forward to your business stakeholders, as opposed to dollars and cents, is to say, here's the concept, here's the idea, here's what we want to understand, here's how we want to try to understand it, here's the data we have, which is imperfect. so here's the approximation I'm going to make to study this concept. But in addition, now that if you believe this is important, we also now need to go make these investments in new data or in better data or data, the right kind of data or the data engineering to go produce those kind of concepts. Because I think ultimately all data scientists come up against this hurdle that it turns out that the data we need is not the data we have. How do you go make? I think the real value proposition you have to understand is what is the value prop in going and making those data investments, and that's and that's usually I think dollars and cents is certainly one way, but I think there's some deeper psychological ways to get there.
Mm-hmm. Yeah, I think you made a great point. And then that reminds me of a project I did early in my career. I talked to my manager about, we don't have enough data. And my manager told me, just imagine you can have all the data. Don't think about the limitations. And then you want to solve this problem. What are the data you want to collect? And then formulate the problem that way instead of just limit yourself to the data you currently have. And then, like you mentioned, you can find a proxy. Maybe you need to have a project to recollect the data. And then that's how you really solve the problem, finding the right fundamentals.
Yeah. No, it's a complex issue. And now, of course, with the cloud now, I mean, companies have so much data, right? There's so much more than we even realize that is there. But I think it's really challenging to know what variables to measure and collect, because I think ultimately the concepts are always higher order concepts. It's not going to be like raw sort of telemetry. Typically, it's telemetry that comes with the system, and now we have like a variable that we want to develop. And I like using, I'll just say my own biases, I sometimes like using the word variable rather than metric. I know a lot of people like to use the word metrics and being metrics driven, but metrics suggest that things are far more concrete than they are in reality. Because in some ways, the hardest challenge is what are the right metrics to build. So there could be many metrics. The other way to think about it, there could be many metrics that are signals against one variable of interest, right? There's a real variable of interest, something that's very latent. It's not directly measurable. And I can start to collect metrics that give it a sort of a multidimensional story. And I just mentioned that because I don't think we use that word variable enough. And going back to the original thing we discussed, researchers will use the word variables. We will say, what are the variables of interest? We'll never use the word metrics. And I think that's another bit of language that can make some of these conversations a little bit easier.
Yeah. And I think initially when I found you on LinkedIn, I saw a very interesting post you wrote. Also, like what we just talked about, right? Sometimes you just look at the data and then you build a data-centric model. And then you suggested that the model quality is more important than the data quality. So can you talk more about that?
Yeah, no, I'm actually almost directly related a little bit to the conversation we were just having. So I think my first experience in trying to impact a decision was very much tied to this issue that I realized that we don't have maybe the data we need, or the data I would need would require some hefty engineering work, right? I didn't have that engineering team available to me. And so I felt stuck. I felt paralyzed, right? I felt like I can't make any progress. And I'll just tell you a personal anecdote. I had a kind of a friend, mentor, someone with many years of Microsoft experience who was kind of helping me navigate some of my challenges. And I said to him one day, look, I feel stuck because I need this data. I can't get this data. I'm not able to make progress. And I feel like I'm spending all my time in meetings and having conversations. And I'm not able to progress on this model and on this data. This is what the business needs. And he said something that was very interesting that really stuck with me, which is, he sort of said in so many words, I'll have to paraphrase him, which is, Amit, you're missing the point. Those meetings and conversations are your data, right? Something very powerful. It's like, what does that mean? That's like so fascinating. And then it hit me like a ton of bricks that when I'm having a conversation, when I'm having a discussion, apologies, clear my throat. I'm sort of collecting data, right? I'm collecting context. I'm collecting sort of an understanding that I can almost, for lack of a better word, just make up the data. Like I have a ton of context. I know a lot based on these conversations. So why not just proceed with the model even if I don't have the data, right? Like there was like this great experiment. Like, these models have parameters. I don't know the parameters. But I know I have a great amount of like conversational understanding. So let me just kind of make it up. Let me spoof the data, right, if you will. Okay? Very low data quality, but really what I was testing is this model going to sell, right? Is this because the model is really the thought process, and that's really kind of the origin of that comment I made. That really in that experience I had, the data quality was really fourth or fifth order. What really mattered, I could have had the best data in the world, had I not really. How do I test the model without the data? That was the interesting part in that experience for me. And I realized because we're focused so much on getting the right data, and that's what I was also trying to do. I was also stuck in that trap. We're not really iterating on the models, right? We're just sort of iterating on the data, maybe the algorithms, but is the framework the right framework? Do you need a different framework? And I associate that with what I'm going to call model quality. Like, does the model fit the situation? Does it fit the problem? And sort of, I think a good experiment is, imagine you have the perfect data in the world. Is this going to start to almost like logically play out? Where would this go? Okay, I have the data. I have this model. What would happen? What would happen? What would happen? What would happen? And that's really what is most important, I found, in my experience, to test. Because once you have a very robust modeling approach that's aligned to the question, and you have several interested parties and stakeholders, getting the right data is a much easier conversation. Like it becomes almost a mechanical detail. Okay, yeah, of course, yeah, of course we need to get that data. Well, why didn't you ask me sooner? And so it's an interesting distinction. Now, it turns out in that context, in that particular story I was just telling you, getting data quality was not, the data was very low quality that we ended up using at the end, but that that was not a limiting factor for the business conversation to get impacted by the approach we developed. And so that was really a function of model quality, not data quality.
Mm-hmm. Yeah, thanks for sharing that. And then I think when you say model quality, you are talking about more of the thought processes, not specific like a machine learning model, right?
Yeah, I mean, machine learning models can also be explained. I think that's the other thing that I think is, even if it's a black box, like, yeah, I have a Y variable, an X variable, here are the X variables. Like, here's just even a machine learning model, even if that's your modeling approach. I'm not suggesting everything needs to be clean, interpretable, transparent models, but a machine learning model to a problem is an approach to that problem, right? So can you test the approach, right? Let's play it out. Does the approach work? Does the approach work?
Yeah.
Because it could be that within machine learning, there's thousands of models, right? Which one should you be picking? And I think this also gets into, if the goal is not purely predictive accuracy, but something else, right? It sort of goes beyond just predictive accuracy. The choice of model deeply matters, right? I think if you're just focused on predictive accuracy, sure. But I would argue a very limited subset of interesting business problems are just going to be about predictive accuracy.
Yeah. And, now we start to talk more about like accuracies, outcome of the model. So as a business leader and a scientist, when you evaluate a data science projects, what are you looking for?
And probably first and foremost, I think there's two big ones that jump out at me. Is first relevance. Okay, is this relevant to something that can be explained without too much, lingo, if you will? Just, is this relevant to something real that we can, maybe explain to a layperson, right? Why did this matter? And that's why we study. So I think having a real question or motivation is critical. And the other part, I wouldn't jump to accuracy right away, because at the end of the day, accuracy, I mean, we do have to realize that data science is within a broader engineering space. And so accuracy ultimately can be engineered. Like when you have the right approach and you have the right data and you have the right thought process, we can get accuracy. There's ways to get accuracy, but so I wouldn't jump to my second pillar is not actually accuracy. Was the solution, this is going to sound odd to you perhaps, was it interesting? Like, was this an interesting way to kind of cut at that problem? Like, is that like the way you took the data set, the way you built the model, the way you framed the issue? It's really that framing. All data science problems are going to go from a human stated question, right, to a framing that turns it into a data science problem, right?
Yeah.
And I look at the question and then the framing, because once you have the question and the framing, the data science technique is almost one-to-one with those two pieces, right? You have a question, you have a framing. It basically, A plus B equals C, right? Of course, I'm going to use k-means, right? Okay, because and that becomes straightforward. Did I implement k-means? Sure. Did you take the output then? And then I think the third one I focus on is then influence. Like okay, so now you've had the problem and the approach or the framing, and that meant that we applied certain techniques, we collected certain data, we generated certain output. Good. I do think it's important. My own stance on data science is that to make sure that was done in a way that's part of software as well. I think there's a tendency to kind of get a little scrappy sometimes about getting data pulls and quickly putting like a storyboard together. But I do think even if you're going to apply technique on certain data, is it reproducible? Is it robust? I think those are also like from a functional excellence perspective quite important. But then the last part is did this have influence? This goes back to our earlier conversation, is not necessarily in terms of, I made a Y dollars for the company, because I think it's very hard to attribute, revenue success or cost success to any one project or person, right? These companies are very complicated machines, and it's almost hard even just to do it to the CEO. It's hard to say what is the value of the CEO of a company, let alone like a data science project. And so I would focus on influence on, what decisions, actions, outcomes, understanding did this generate, and that obviously gets a little bit into. There's a peer review element of this sometimes that kicks in. And by the way, that's not so dissimilar from academics. Like when I write a paper in academics, who's to say that's an important paper? Who? Other academics. It's not like there was some metric I created or some societal outcome I created. It's just people, you influenced how people thought about a problem, and that's called the peer review system in academics. And I don't think it's that different in an organization. Even if it was, I illuminated, let me frame it to you, let me even say it to you differently. Even if person, X said, knew they're going to take some action, A, and data science came in and looked at the situation and did all this analysis and did all this and told a wonderful story and used a fantastic framework. And even if it comes back to person X, and let's say they come back and say, yeah, in fact, you should do A, right? So in some sense, nothing has changed, right? We did all this work, but we're still doing action A. I would still argue the data scientists had incredible impact and influence because we feel much better about taking action A, right? We know we're not flying blind. We have a real understanding of the risks and the trade-offs and the context, so that when I step into the future and the world changes and action A is no longer obvious, that understanding is now kind of it's carrying with me into the future. And I think that's the other critical part of success, is that I think one challenge with data science is that a lot of the insight becomes lost in tribal knowledge, right? It's sort of, we want to make it part of organizational knowledge, right? Organizational understanding should now be kind of like, it should be enhanced, even if we continue to take the same actions we previously thought we were going to take.
Mm-hmm. So how can we prevent that knowledge just become a tribal knowledge? How do we share that with our organization?
Yeah, this is a very hard question, and I think it's so organizationally specific in so many ways. I mean, I think at a minimum, creating data science assets that are real, meaningful software assets. I mean, I think at a minimum, we should be in system. We should have like tangible structures, in Git. Mm-hmm. It's part of software. It's a software enterprise, and I think that's a very important part to embrace. And so, in that sense, there's continuity, so that if at a minimum, let's say we took decision A based on understanding I just suggested. And now in the future, the world changes and we want to revisit that understanding. We should be able to kind of, just like Git lets us go back in time, we should be able to version control how we came to that understanding, right? So part of it is just sort of software, so it helps create a little bit of that institutional memory. But then I think also, this is also where codifying the understanding in some organizational structures is also, I think, part of the story. So I think, and how that works in different organizations is different. But whether it's a recurring set of meetings, it's some type of sort of deep dive offsite, or just something that keeps the organization learning over time. It's a process that has to get kind of formed, and different companies, I think, just have to go about it in different ways. And I think it's still early days. I think most of this has always been done informally. I'm a big fan of formalizing. Like if we're trying to learn and we want to kind of avail ourselves of this understanding and not forget, because I think we make the action, then we go to the next action, we forget. That can only happen through good structures and processes, and I think it's so critical to develop those.
Yeah, and I like that you mentioned the engineering aspect of it, because when we solve a data science problem, in the beginning it's science, but in the end it's always we need to use engineering to scale the data science project and also make it into some type of data product. It could be automated reporting or some type of, for example, recommendation engine, things like that. And also, even if a project failed, data science can also recycle some useful elements, the scripts you wrote or some tools you built during the project that it can be reusable in the future, right? And also, do we document our project, even the failure? So when you look back, you know how exactly you made the decision, so you don't have to make the same mistakes again.
Absolutely, yeah. And so that's really, and I think part of this now gets into, it's hard to do engineering as well, because good engineering practice, good hygiene always slows you down, right? There's always kind of like the need to do everything you just suggested requires, there's overhead now. We're adding overhead to the ways we work, not just the work, not just what we work on or what we did, but how we did it now really plays a big role. And this is the sense in which it's even data science has to always have a strategy, right? Because the very definition of being strategic is I think the definition I like to use is sort of being bad in the service of good, which is to say you have to be bad at some things to be good at other things. And that does mean that not every problem that involves data, okay, because the company is going to have countless data problems, right, is necessarily a data science problem, right? And because I think to do that hygiene, to do that process, you can't work on everything, right? It's just going to be impossible because there's just going to be way too much incoming. And so having a strategy of what matters, why it matters, and kind of the purpose of it is to create knowledge and learning. But we're not going to create knowledge and learning if we just kind of take incoming requests and fire out data, because that's not going to create any kind of systematic learning. And that's really where data science has, I think, a huge opportunity to become more strategic inside of an organization, which is the very art of being able to say no, which is often hard, right? If somebody's asking you to do something, it's hard to say no.
Right. So, for example, if you ask a data scientist something and then they say no, what is something they did that convinced you that they did say no in a it was a good decision?
Well, and I think the advice I like to give data scientists is it's never just a no, but it's a principled no, right? It's a no because there's a basic principle of work that's determining it. But I don't think it's ever like a no directly. I think it's, well, why this versus that, right? And we're doing that right now. This has to be done a certain way. This is an imperative, urgent business need. Does it fit the principles or scope of what we're trying to accomplish right now? And if it does, then you should do it, right? But if it doesn't, because I say not everything that involves data is data science, right? I mean, think about it. Like, accountants have existed for 200-300 years. They use data, right? I mean, I think kind of like there's the notion of data and data science are a bit distinct. And I think I go back to data science is a problem-solving enterprise, which means it needs to have some scope of problems. And so if it fits the scope of the problem, it makes a ton of sense, right? If it doesn't fit the scope of the problem, then at least there's a conversation. And from that conversation can emerge a principle of no. So I never want to encourage anyone to be disagreeable just to be disagreeable. But I do think if there's a reason, hey, I want you to do, I would love to tell you, guy, I think this is really important to me. Can we go work on this? And it would be like, well, that is interesting, but I'm working on this right now.
Yeah.
And you just kind of have to understand the relationship between those two and the scope of work, and maybe there's a common thread there, right? That's sort of a really like kind of unpacking something you said a little bit earlier, which I thought was excellent, which is asking a little bit of the why. Well, why is that important? Why do we need that? And I think usually from those conversations, what's usually discovered is that there's a common interest more often than not, right? It's usually like, I'm doing this, you need this. This seems to take me off my course, but wait, if we can get to that common, we're actually both trying to solve the same problem, just coming at it from different ways. That's a perfect formula for collaboration.
Yeah, that's great, because yes and no. Sometimes doing a project is not just a binary. Oh, I choose this, I don't do that. It could be, like you mentioned, it could be some synergy between project. And then every time someone asks you to say something, do something, or you feel you might need to say yes or no, it's always basically a conversation of realigning your priorities, right? The roadmap on your plate. So, I think previously a very interesting thing you mentioned, you mentioned you think every data science would benefit of a little bit, a light kind of MBA, when you mentioned when we think about the impact, right? It's not always directly dollar amount. I mean, of course, I think there are models that directly impacting, some money a business can save. Those are some cases we can measure, but a lot of times I think it's hard to tie the data scientist project to a dollar amount. I think that sometimes data scientists create a lot of stress for data scientists, because if an organization only evaluate people this way, then sometimes they can lead to projects that are kind of short-sighted, and we're not really focusing on the most important thing. Like you mentioned, customer experience or product quality. Sometimes it's hard to attribute the data science project to a dollar amount. So if you think about those business fundamentals, what are some other elements of MBA you think data scientists should learn, or some mindset we can adopt?
I'll say the first subject all data scientists should know. This is going to sound like I'm contradicting myself, because we just said that putting into dollars and cents shouldn't reign supreme, but everyone should have a basic grasp of financial accounting. I think it's the most essential. And when I got my PhD from I graduated from University of Chicago, back in those days, they would let. I actually graduated from Chicago. Was interesting because it had an economics department also in the business school. And so as a doctorate student in the business school, I was actually able to take MBA classes, and I actually earned an MBA, if you can believe it. So I'm actually a Chicago Booth graduate, I guess is what they call it now as well. Yeah. And so I was forced to actually, the one class that did not intersect with, because a lot of my PhD classes counted towards the MBA. So I didn't have to take another set of classes, but there was a few, one or two that did not, one of which was financial accounting. And this was a very painful course for me to take, because it just felt so different, and there's a lot of rules. And I remember I tried taking this class 3 or 4 times, and I kept dropping out. I'd only make it through the first 3 or 4 weeks, and I dropped out. So, and then it came down to I had a graduation date, and they said, unless you take this one class, you're not going to get the MBA. I said, okay, I got to go quickly take this class. And it turned out to be one of the best classes. When I never used it until I actually came to Microsoft. When I came to Microsoft, suddenly all that stuff I remember, right? Cost of capital, what is gross margin, what are cash flows? I think it's really hard, if you're going to even try to position your work as having financial value, there's no way to do that unless you understand how financial value is measured, right? And so it's not just there's nothing called profit, right? There's 30 different kinds of profits, right? And so so I think that's one. But as I said, the other one that I think is important is strategy. I think strategy is a very important sort of area, and not a lot of people learn it formally, and that's something from an MBA perspective that you pick up kind of ideas about strategy, what is strategy, and what does it mean to be strategic? And we all want to be strategic. What does that mean exactly? And I think between strategy and accounting, and then of course understanding economics, I think is helpful. I think understanding the fact that the biggest risk of working as a data scientist in an organization is that you only see the world through the prism of inside the organization, right? You are looking at the data in the org, all your stakeholders are internal, so you have an internal model of reality. But the real reality is that your organization lives inside of a market, lives inside of an ecosystem, lives inside of an economy. Yeah. How do you think about those? That's what your CEO is thinking about, right? That's what your CEO is looking at. How can you empathize with your CEO, right? At the end of the day, we all need to have empathy for each other. A little bit of understanding kind of markets and economies and competition and regulation. I think even if you don't get into the full depths of it, getting some of the conversational aspects, I think it's those are think about it as your data science skills start to really get more ROI when you start to put those when you put those complementary sort of skills on top of it.
Yeah, I think that's really important. Especially, I like how you define a data scientist role. You're a problem-solving partner, right? And data science is just a tool you have. And in order to solve the problem, we need to understand financial impact. You mentioned strategy, economy, not just within your team, your organization, what's going on in the world, in your industry.
Yeah. And it's hard. And
Yeah.
What's great about data science then, of course, is that, going back to something I said earlier, once you understand those things, we can start to put them into our models, right? That's great. Like we can put financial concepts in the models and put market concepts in the models and put strategic concepts in the models, and it makes the models richer and more interesting at the end of the day, because that is fundamentally what persuasion and influence represents. Like, did somebody want to listen to what you had to say at the end of the day? And the more of that you can bring into it, I think the more persuasive is your message ultimately.
Yeah, definitely want to ask more about like influence and persuasion, but just to double click on the strategy part you mentioned, to you, what is a strategy and how can data scientists use strategy in their projects?
It's a great question. I think the first question a data scientist should try to understand inside of an organization is, do they know their organization strategy, right? Can they articulate what is the strategy, right? And usually there's not like a strategy white paper, right? It's not like, oh, here's our strategy in a single nutshell. And there's different sort of versions of strategy. But if you go back to something that we discussed earlier, which is if you're not going to look at financial performance, what is it that you want to try to understand? I think ultimately you want to understand value. Like, are the actions and decisions and products and services we're building creating value, right? And so so one simple definition of strategy is are you creating value in a sustainable way? Okay, when I mean sustainable is that it's not going to be competed away, right? Like your value that you're creating, which is ultimately, just let me give you a super simple model. Like if you have a person buying a product, right? If they have a willingness to pay, which is their value for the product. You have a cost of producing the product. The value you create is the difference between those two things, right? So, I mean, the basics of strategy are you want to drive up willingness to pay and you want to drive down willingness to sell. Those are really the pillar of strategy. Now, when you do those things, I think what gives you that external eye is, are you doing it in a way that's sustainable? So said another way, that's where sometimes we talk about differentiation or competitive advantage, those words, right? But what do those words really mean is that when I have this gap, it's not just, the creation of value. There's also what's called the capture of value. Can you capture the value, right? So you capture the value by having some kind of a price, right? You sell for a price, and so then I make up the gap between price and willingness to sell, and you make up the gap between willingness to pay and price. And so our ability to have a premium really relies on having a sustainable advantage. And then I think what makes strategy interesting is when you look more at what does it mean to be sustainable, we oftentimes talk about differentiation. Like, you probably have heard that word a lot. Like, I want to be differentiated from my competitor. I want to do something different. But I think, doing something different is just it's a marketing slogan, right? I'm different, you're different, we're all different, right? I mean, what it really means to be different is like, are the activities I pursued inside of the firm to create the product that has this value, are those easily imitated, right? If those are easily imitated, or said another way, they should be unique to the unique competencies your organization and your firm and your talent bring to the equation, which leads to a very interesting question that I don't think anyone has fully solved. Is like, how do you then use data science as an internal competency to go create that differentiation, right? To go create that sustainable advantage. Because at the end of the day, any organization's greatest internal asset are its people, right? It's problem solvers, right? And so I like to position data science as a form of competitive advantage to go create that sustainable differentiation. Like, if we go do data science in a new way that not everyone else is doing, and in a way that's going to be unique to our organizational culture, that's going to create that strategy. Like, we're part of strategy now. And I think just to even understand what that means, I think it's very healthy for data scientists to just to take a look. And I'll just mention the guy who put strategy on the map as a field, Michael Porter from HBS, who wrote this kind of concept of the 5 forces. It's from the 80s and early 90s, but it's still gold. And I highly recommend anyone just to go read some of the old work from Michael Porter. It's really fantastic stuff.
Yeah. Thank you so much for sharing that. And do you have an example of how did you build your data science team to make it, make your organization different?
One thing is that I think within the data science teams we used, and it always caveat, it's different for every company. And but I think one thing that is a little different is to not actually make it a data science team as much as you can believe that, but to actually make it a cross-functional business delivery team. And so I think in a team, because think about the team, there's data science, which is using data to solve problems. And then there's data science as a degree that people earn in schools, right? Here's a degree, and I have this degree, and that gives you the job title of data science. I would almost distinguish the organization's data science from the particular degrees that people happen to hold. And so if you really want to solve a problem, it's very powerful, I think, to pair a traditional data science degree earner with an economist, with then a program manager or a project. So you start thinking about, as a very successful data team, it's a cross-functional team, right? It's all data science at the end of the day, but it creates a very kind of holistic form of business delivery. And I think that is something maybe a bit different, because it pushes the boundary of the title. I think people get maybe a little bit caught up in the title. Because you have a certain skill set, you are called a certain thing.
Right.
But that's maybe almost orthogonal from what data science should mean as a business function that's providing strategic value.
Yeah, I agree with that. And sometimes we do need to wear the hat of a program manager ourselves, or product manager, and learn some engineering. So be flexible, be willing to take on other responsibilities in order to really drive impact for your data science project. Yeah. And previously, in our previous conversation, I really like something you mentioned. You said every data scientist is a behavior scientist because you're there to drive changes. And you just mentioned understand the organization's strategy, the goals, so that's easier for you to convince people to influence. So can you share more about how can data scientists best drive influence, persuade people?
Yeah, and the approach that I think is very powerful here is to actually think in terms of being a product manager yourself. So as opposed to, this is another little pearl of wisdom somebody handed me. They said, Amit, you need to stop talking about this model because we know you love your model and this is great. As opposed to calling it a model, think about this as a product, right? If your model is your product, then let's say you're a product owner or a product manager. What do you want people to do with your product? Well, you want them to use the product, right? You want them to adopt the product. So you take a very user-centric approach, right? So suddenly it's a little bit like design thinking. It's you sort of models, data, all the stuff. At the end of the day, I'm going to call everything we did, we built some kind of a product. The product can be a slide deck, can be a product. A structured meeting can be a product. All of these things are different products because at the end of the day, they have users. And I think taking a user-centric approach and working backwards from the user needs and really understanding the user, which is very much like design thinking. And one of the exciting parts this is something I began to develop as my own thesis for how to be successful in data science or how to make data science more successful in organizations. I developed when I was at Microsoft. What's exciting about coming to Airbnb for me is it's a company that we're design is deeply infused in the DNA of how it solves problems. And so kind of bringing design thinking into data science projects, I think is a very powerful formula, because once you understand the user and the user personas, then you understand what you need to build to have that persuasion, right? What does success look like, as we like to say in data science products? And success, if you have a product, is what? User delight. The user was delighted by the experience. And so ultimately, when I talk about we're all behavioral scientists, we're building experiences. I like to call them decision experiences. You're building a decision. You're building an experience for how you make a decision. So one experience is put a bunch of data on a table and make the person stare and squint at it. And maybe that's a good experience. If that's the kind of if that's the user and that's what the user needs, you build for that user, right?
Yeah.
If a different experience might be, don't start with the data, start with the story, start with the strategy, start with the business narrative, and kind of slowly introduce the data. That's a different experience, right? And so I think this is the sense in which I think the key trick is having a user in mind, even if it's a user persona in mind. And starting to work backwards from the user, which is often not, this is distinct then from starting with the data. If you start with the data, I'm not suggesting you can't get there, but you'll just go through some more frictions and hurdles. And I think ultimately we should do both. Like, you should go look at data as yourself and be interested and explore and experiment, but then also have a user in mind who you want to influence, who you want to understand. And that's where those conversations are so important. When you're having those business meetings, make it very intentional. You're collecting data because you're understanding the user, you're understanding the context, and you're understanding what is the need that will overcome that persuasion barrier.
Yeah, I think that's a great point. I think sometimes as a data scientist, we don't know how people are using our product. So once we deliver the project, even if you might not get evaluated by that, just have that curiosity, go to the engineers or the product managers. Hey, how is that launch? What's the final product? How are people using that? And then maybe talk to user researchers, really, and or maybe just use your own use a product that you developed as a user to see how it works, to develop that empathy. I think that's very important.
Yeah, completely. I couldn't agree more. Yeah. I'm glad that you're doing that in your own role. That sounds like you've already embraced some of these ideas.
Yeah, it's funny that I used to work in a team that runs A/B testing for entire Amazon retail. So sometimes in my browser, today Amazon's website looks a little bit different. So I'm in one of the A/B testing cohorts, so I can see what's going on. I can see whether I like a treatment or not.
The most persuasive A/B test is the sometimes I call it the existence proof of one. Just having one direct experience can be very very persuasive in the end. Versus focusing on just having large sample sizes. But that's good stuff.
Yeah, so I'm glad you also brought up design thinking. I think you also mentioned the data scientists can learn some economics principles. That's from another post I saw. It was I really liked on your LinkedIn. So you talked about forecasting problems. So a lot of times when we think about forecasting, we fitting a model using regression or tree-based, but sometimes if you're forecasting some sales, there's also demand playing into supply demand playing into the picture. So we need to understand some causal relationships. And can you talk a little bit more about that? How causal relationship play into forecasting problems?
Yeah, no, absolutely. So I think if you go to the most basic causal relationship in the world within economics is just a demand curve. So the law of demand says that as the price of a product falls, demand increases, right? So if you ever take an economics class, you learn that the first thing you should learn, sometimes people don't start there, but is that demand curves slope down and supply curves slope up. And one thing obviously interesting, that if you were just to go collect data on prices and demand, like imagine just doing a regression of quantity on price, is that you might find often that if you just run that machine learning model or run that regression or whatever you want to call it, that the data will actually suggest the opposite relationship. That when price is high, when something is high, you'll often find that quantities are also high in most empirical data sets. Is that and without a demand curve in the back of your head, you might infer that, wow, raising prices is great. You make more money. Like you have higher prices and you have more demand. It's a win-win. You just found what they sometimes call a money pump. This is like a money machine. And ultimately that's obviously not correct. There's something missing there. But to understand what's missing without having like a model of reality, and this is what I sometimes talk about with causal inference, that word is a tough word, because there's causal inference, which is to say, I want to look at the causal impact of X on Y as opposed to the correlational impact. But then there's also, what are the causal structures that would even tell you that relationship existed, right? And that's the thing. Sometimes when we do causality, what's a little bit different than correlational work or predictive work is that we're looking for what are called invariances. So with predictive work, if the environment shifts, right, if the environment changes, then that predictive relationship is also going to change, right? So that's the sense in which the data history may not be predictive of the data future. And I think this is where machine learning models really struggle, right? You have to retrain the model. You've got a cold start problem and all these things. But if you could go like one level deeper into, there was some causal structure behind those predictive relationships. What makes that really valuable is that those structures tend to be much more invariant, which is to say, even if the environment changes, the demand curve is still there, right? There's still a demand curve, right? The demand curve didn't go away. Prices and quantities can go up and down because you have market shocks and different customers and there's a depression. But like, there's still this thing called the demand curve, and it's still down there. And it's if you can start to touch those things, then when the environment shifts, you will still have an ability to predict and understand and be robust to these perturbations in the environment. Because I think one of the challenges with causal work, A/B testing, and just that baseline kind of causal work is that it's very static. It's very point in time, right? Now the effect of X on Y is A, right? But when I go launch a product or when I go build it, the world is dynamic. You're in a dynamic setting. Like, things change. You have multiple products, new customers, like all these things are changing. None of that change or dynamism was in an A/B test. It was in the kind of like basic causal inference, and that's why getting to those deeper structures, and that's where economics I would encourage you to data science to think about it as just a language for data science. I don't think there's anything specific about. I think the thing that connects it is that oftentimes data science problems inside of businesses involve economic variables, right? They involve things like prices and quantities and customers and costs and competition. Like, these are all of those things you will find in economics textbooks, right? So we're not utilizing all the information we can by ignoring all these models that have been produced that kind of give us insight into that invariance. Now, it's a little bit harder to do it that way, but I do think it has a lot of value to at least even understand that behind your predictive machine learning model is a demand curve, is a supply curve, is a cost function, is a production function. These are things that are underneath the data that that are really powerful if you can kind of even just understand them, let alone measure them.
Yeah. Thanks for sharing that. And I look into some books about, economics or causal relationship. Those are very textbook kind of, it's hard to learn sometimes for data scientists. So for us who want to learn more about, economics thinking, do you have any resources to recommend, or should we start with just looking at those concepts?
Yeah, no, it's you were. This is one of those books that I feel like I want to write in my elderly days. But there's not a lot, I think, that's been written, unfortunately, and this is a problem of the economics profession, to make this approach accessible to the broader data science audience. I will say that from the computer science side, there is the work of Judea Pearl that looks at what he calls like structural causal models, which is, it's in line with the economics tradition. So I think, and so he has a really fantastic book called The Book of Why. And I think that tradition in the book is in the same spirit as the tradition I'm describing with you. I think the thing that's missing there is actual discussion about demand functions or production functions or these kinds of like economic constructs. And that unfortunately is a little bit of a gap. But I think once you understand what is a structural causal model, going from there to some literature is not nearly as hard. I think the trick here is that there are accessible texts, but they've never really been intended for a data science audience per se. So I would say like in antitrust, so which is basically a version of teaching lawyers economics, so they can use it in cases. Like those books have been written, and they actually kind of talk about these kinds of issues, but with a different audience in mind. And so I think part of the trick would be to start with like something like Judea Pearl to get what is a structural causal model, and then shift off to some of these more sort of legal
interesting
areas. And I'm happy to give your audience some references after the talk to kind of look at the nascent literature on the subject. But it's a void in the world that does need to get filled.
Yeah, that would be great. I will add the references in the show notes. Cool. So you do research around decision making, and I don't think we have time to get into all the research, but I'm curious that in our decision making process, especially at work, we think we are launching a project because we have some evidence, we have the data, but sometimes we make decisions because of a feeling we want it to happen. And then we have that biases, and then we look for the data to support our decisions. So how do we overcome those biases at work?
This is an important issue. I think the key thing with bias might be first to not start, but I think if we start even saying people have biases, that people get defensive right away, is that it's very hard for people to be self-aware of the fact that there are certain kind of decision biases. I think the word that behavioral economists would use sometimes is this word heuristics. And so we have sort of two modes. I think the standard decision-making sort of idea in behavioral economics and psychology that's out there is that there's sort of two modes of thinking, what's sometimes called fast thinking and slow thinking. And they would sometimes call fast thinking system 1 and slow thinking system 2. If you think about slow thinking is sort of rational calculation, or like rational decision making. The kind of decision making you would learn in an economic model would be slow thinking. A lot of your decision making, however, is governed by fast thinking. And fast thinking is very associative. It's very pattern oriented, and it extrapolates from small data very quickly. Actually, Daniel Kahneman, who's a Nobel Prize winner in economics, one of the founders of behavioral economics, called this the law of small numbers. The
Yeah.
mind works with the law of, we over, we read into small data sets very, very quickly. And that's, so I think the biases to sort of not necessarily look at data or reality in a rational calculus sort of way is deeply embedded in genetics. Like it's not something we can overcome. And Daniel Kahneman himself was the expert on it. I think he said in a famous quote that every bias or decision paradox I've uncovered, I make every day in my ordinary life all the time. And so, which is to say, no amount of knowledge. It's like vision. Like, can you look at is your vision going to look different? No, this is hardwired in our cognitive machinery, which means to overcome these biases. I think this is sort of getting into the art of persuasion a little bit, but we're going to go look at data in a rational way using our system too, right? We're going to do like slow, methodical, intentional analysis to come to some understanding. But to make that understanding real to the user, it has to work through their fast thinking sort of structures, right? So you have to somehow trick your fast thinking side of the mind to just think fast about what you're doing. And that's why, making things intuitive is so important, right? If it's intuitive, your fast thinking gets it right away. If it's counterintuitive, it can't, right? And I think that's really the one of the, I think the lessons from decision making is that to debias or unbias at some level is not education is helpful. Don't get me wrong. And I've been an educator for many years. And so I believe in the value of education. But that alone is not the answer. Like, let me educate you on why I'm right. I mean, you have to get the mind to see that it's right. And that's where I think having some awareness of not just what are the biases, but where do they come from? Like, what are those mental heuristics that are sort of hardwired in people's fast thinking sort of minds? I think that's very helpful just if we want to influence decision making.
Yeah. Thanks for sharing that. And if you are mentoring a data scientist today, what type of advice would you give them?
I would say this is a very exciting time to be a data scientist. There's so much data in the world. So first of all, I would commend them and congratulate them for becoming a data scientist. And then I would say, ask bold questions. I mean, I think that's the number one thing is sort of make the question itself well beyond the capacity of the data or the data science they happen to know to address. Because unless you have a really big question or problem, your effort is not going to have the kind of impact or influence that it could possibly have. And so I would say the number one piece of advice is be really grounded in a question or problem of the world that you want to solve, and not married to your particular technique that you happen to learn in school. And I think kind of like your technique is really important because it gets you in the door, it gets you access, it gets you, because obviously the technique has some value, that's why you're there. But then but to go forward, is the classic line of what got you here won't get you there. To kind of progress with it, really to embrace big, bold problems and own the problems. I think kind of the other aspect is feel like you have ownership on the questions, right? If you don't have ownership on the questions, then it's really hard to really know what to do, because there's so many. We just talked about decisions to do a data science project. I don't know what it's like for you, but there's thousands of decisions you have to make, right? You have which data, which model, which technique, which algorithm, all these little, how do you manage that complex tapestry of decisions unless you have like a sense of a North Star, a sense of the problem? That's where all that decision making becomes much easier.
Yeah. Thanks for sharing that. And before we wrap up, what do you think about the future of data science, data scientist role, with all the changing and merging of data science, machine learning, AI, economics?
It can go a lot of different ways. One can argue data science is might be a thing of the past, like in the sense that what's going to matter more are having those domain specific sort of titles and labels, or being an economist, or being a machine learner, or being sort of operations research, like, having that is going to matter maybe more than the catch-all data science umbrella. Or you can argue, and this is a different way that the world can go, is that data science encapsulates the best of all of those, right? It could be that it's a highly multidisciplinary field, and so I think being multidisciplinary is hard. I'm optimistic, though. I'm optimistic that data science is a critical business function. It's unlike a lot of technology functions in the sense that it really has a human stakeholder at its heart, and I think the more it does that, the more it will be successful. The more it maybe becomes a little bit lost in system and process, then I think there's some risk for the field in getting maybe a bit overtaken, because data science technique gets stale very quick. I don't know if you realize that every 2 or 3 years there's a different wave of new solution, what's hot and what's current. It just keeps changing, right? So to stay ahead of that, getting grounded in the problem, getting grounded in the user, I think that will be a good future for the field.
Right. So the more like problem solving, the human part you put in your work, basically the less automation you do, the more valuable you are as a data scientist.
Yeah, go higher. You got to go higher up the stack. It's all about it's all at the end of the day, it's all a knowledge stack, and so you want to go. The world. This is getting commoditized away. Go one step higher, one step higher. But you do want, and I think there's the challenge of being. The other thing I would say is, the last piece of advice is to be an active learner. I mean, you should be learning all the time. I mean, I am a dinosaur. I'm an old person, but I'm I have to learn all the time, because it is. There's so much happening, and just kind of keeping your eyes and ears open. We've met on LinkedIn, for example, right? I mean, I think there's some great. Your show has great knowledge, right? You don't have to sit there with an encyclopedia or a textbook to get knowledge. Just listen, learn, ask questions. I think that mode of operation has to kind of continue, because the field is just so rich, and I think that's the other key to using machine learning, using economics, using traditional forecasting, A/B testing. How do you put that all into one soup? It just requires continuous learning as well.
Yeah. Thanks for sharing that. And what is something you're excited about in your career and in your life, something you're working on you want to share with us?
Well, I think kind of based on what we've been talking about, I have been working on kind of a grand unifying theory of of decision making with data, and I'm still collecting, I think, data on that, just in terms of how do we make this successful in the fastest possible way? What are those best practices? I think there's so much that's been experienced over the last 10 years in data science. There are certain kind of principles and that need to kind of get explained, but in a way that's not authoritative, you have to do this or else, but really that sort of makes sense in terms of the themes we've been talking about, problem solving and the like. And so, one way I've been trying to approach it is maybe not to write one big book on it, but just start with a LinkedIn post here or there, trying to look at, maybe starting to get into a little bit of Harvard Business Review type articles, and so I'm trying my best to take my organizational learnings and continuing, I'm at Airbnb now, is to really solve Airbnb's most pressing problems. But from there, developing kind of learnings and understandings that really are teachable, that are abstractions, and to bring it back into the literature as a whole. So I'm not there yet, but maybe that when you have me on the show next, I will have a fancy book of some sort that I can showcase with you.
Yeah, I'd love to have you back. I think I'll probably only ask half of my questions, so I'm excited for round two.
All good.
So, for our audience who want to read your post articles, where can they find you?
I think just look for me on LinkedIn. I've been putting more of my material there, and just kind of just developing a single presence. I was at I think it's a fantastic professional site, and
Yeah.
I think we all have a tendency to have our homepages and the like. And I've decided that I'm just going to like use your LinkedIn existence as a form to kind of showcase, not just to communicate really to the world at large. And from there, I'll have links to my personal homepage and then papers and books and the like.
Great. I'll also link your LinkedIn in the show notes.
Okay, sounds good.
Awesome. This is such a great conversation. I took so much notes. I'm going to organize it later. I'm sure the audience also learned a lot from you. And thank you so much, Amit, for joining me in the show.
Sounds good. Thank you.